It has been a while since my last Linux driver tutorial, but today I'm back with a new episode. So let me just clean off the dust of my Raspberry Pi 3 and then let's start. The topic for today's video is mutexes and how to use them in a Linux kernel module. But first, what is a mutex? Well, a mutex gives you exclusive access to a shared resource. This shared resource could be hardware or it could be a shared memory, for example. It doesn't matter. And why do you need this exclusive access? Well, basically, you don't want to have two threads accessing hardware at once. Let's say two threads are writing something out the serial port at once. This way, in the worst case, the two strings get mixed up and you don't understand what the sense of it is. So you need a mechanism so a thread can have exclusive access to a resource, and this is where mutex comes into place. Basically, you can think of a mutex like something like a locker room. So let's say you're at the pool, you want to change clothes, so you're going to the locker room, and then you lock it. Then you have exclusive access to it, and if another person wants to enter it, it's impossible because the door is locked. So another person has to wait until you leave the critical section and unlock the door. And after you unlocked it, the other person can enter the locker room and lock it up, and then the other person has exclusive access to the locker room. So let me show you how mutex works in a simple example. Here you can see I'm connected to my Raspberry Pi over SSH, and now let me cd into my Linux driver tutorials folder. So here you can see the various kernel modules I've already created in this series. And this number 14 kernel threads is an example where I'm showing you how to use two threads in a kernel module. And I will use it as a template for today's video. I will create a new folder I will call 28 mutex. So let me cd into this folder. And let's rename the source file from kthread.c to mymutex.c. Then I will have to change this in the make file as well to be able to build it. Okay, and now let's edit the source file. So this is a really simple example how to use two threads in a Linux kernel module. So here we have a thread function which will be executed by both threads. So it only starts an endless loop or a loop which runs until the thread is stopped. And it will print out a message in a fixed interval, and that's it. In the init module, we are initializing both threads and then we are starting them. And in case of an error, we stop the other thread and shut down the module. And in the remove function, we stop the threads. Okay, first thing I will do is I will change this thread function a little bit. Or maybe first let's start by renaming the print case. So kthread I will replace with my mutex. This will make it easier for me to see the log. Okay, now let's change our thread function. I will create a new delay array here. So, and here I will remove the loop because we will use something different here. So execute it. So let's say down here is our critical section. Is in critical section. And here I will just, normally here would be the hardware access or the access to the shared resource, but in this case I will just use a delay of thread number milliseconds. So for thread number 1 it will be 1 second the delay, and for thread number 2 it will be half a second. And then I will thread is leaving the critical section. Okay, and let's say the critical section should only be executed by one thread at a time. To do so, I will need a mutex. Therefore, let me include linux/mutex.h And here let's declare a new static global variable from the type struct mutex, and I will call it lock. So this is the mutex we will use to to lock this critical section here. In the init module, I will call the function mutex init, and here I have to pass a pointer to my mutex struct, and after this the mutex was init successfully. Okay, and before entering the critical section I have to call mutex lock, and I have to point or to pass a pointer to my mutex struct, and before leaving the critical section I have to unlock the mutex. So what does this function do? This function will check first if the mutex is currently locked. If it's locked, it will wait until it gets unlocked. If it's free, it will lock the mutex and then it will execute this line here. Okay, then we are in the critical section, and then we will unlock the mutex after we have left the critical section. It's important to unlock a mutex as fast as possible. So if you're doing memory allocations, for example, which tends to use a lot of time, do this before the mutex. And also avoid unnecessary sleeps like I'm doing here in the critical function, but this is just for demonstration purposes. Okay, and one thing I will do is here in the module exit function, I will delete these two kthreads stop functions, because both threads will shut down after 1.5 seconds, so I don't have to shut them down in the remove function. Okay, that should be it. Let me try to compile the module by running make. Okay, this is looking good, so let me load our kernel module. Okay, it's loaded. Let's take a look at the kernel's log. Okay, so here we are in our init function. We create thread 1 and we start thread 1. Thread 1 enters the critical section, and here we have the timestamp in, so this is the value in seconds. Then thread 2 will be created and will be started, so thread 2 is running now. Then thread 2 comes to the mutex lock function and sees the mutex is locked currently. So it has to wait until thread 1 leaves the critical section. After a second, thread 1 is leaving the critical section and thread 1 finished execution. Then thread 2 will enter the critical section, and after half a second, thread 2 is leaving the critical section, and then thread 2 finished execution. So here you can see the two threads had exclusive access to the critical section. So I hope you enjoyed the video and learned something and understand how mutexes work. In case you want to support my work, you can buy my coffee on buymeacoffee.com/linux. So that's it for today. Thanks for watching and goodbye.